Well, let's get kicked off.
Mhm.
Yeah, excellent. Well, hey everybody. Welcome to this afternoon's webinar, which is on optimization. My name's Tom Williams. I'm part of the SENTRY team. I'm based in a very warm and unusually sunny England. And on the line today, we have a full set of people. First off, we have Alex Webb. Say hello, Alex.
Hi there.
Hey there. And we have Lorena Garcia from SOAR in France. Say hello, Lorena.
Hi, everybody.
Hey, and we have Roberto De Cosmo from Grupo Cap in Milan. Say hello, Roberto.
Hello, everybody. Hello.
And we have Jose Ramon from Aqualia in Spain. Please say hello.
Hello, everyone. Good afternoon. Good afternoon for me, at least.
Yes, fabulous, fabulous. Good afternoon and
Me
good
too.
morning.
Yes.
And also part of our SENTRY team who are keeping quiet in the background, we have Selena, Patrick and John who complete our panel, and we might see them pop up and ask some questions a little later. So let's crack on with the presentation, and we're here to introduce you to SENTRY. And first off, what is SENTRY and why did the wonderful Patrick Kiley invent this? So we had a problem statement. We all know this. We're all wastewater guys. You have fluctuating influent wastewater. You have the biological changes coming in. You never know what you're going to get coming down the pipe, and you need to know what's going on. And if you're anything like me, you have seen probes that look like this, covered in crap, which is no surprise. We're putting these probes in the crap, literally. But this is no good for our information, especially if this is an optical probe. Any optical probe that looks like this is not giving you a true reading. And the amount of time you are spending going out and checking and maintaining these probes, you know that they're not giving you accurate information. So the very clever Dr. Patrick Kiley came up with a wonderful idea, and this was SENTRY. As we move forward, oh, there we go. That's what it looks like. What's the tech? So this is what it is. Here on the right, we have a probe, and on the left, we have the box that this is connected to. In this box, there is all kinds of communications. It can plug into your SCADA system. It can connect to your Ethernet. It also has a port for a phone card, a SIM card that can connect directly to a cloud. On the end of that wire is this probe, and we have an anode and a cathode on either side of this probe, and in between we have a metal surface where our biology forms a biofilm across the surface, and as that biofilm consumes carbon, it releases an electron, and we track that electron across the surface of that biofilm, and we come up with a signal, and that signal we either call MET or carbon consumption rate, and that matches to the health of the biofilm. And because we're encouraging a biofilm, we're encouraging deliberate fouling of this probe, and we're never getting any problems with the optical masking that you see with other probes. As you can see, it's fairly easy to fit. Here on the left with a high flow, we've just got it strapped to a pole and dropped straight into the water, or maybe into a inlet tank to make sure it's fully submerged, or you can plumb it into a 1.5-inch line, or larger if need be, if you're looking at sludges or other types of liquors. The box itself is NEMA 4 protected, and we're going backwards and forwards with the thing. Is NEMA 4 protected, plug and play, easy to use, and can connect to all your different communication devices. Now, communications is always the big question with any probe, but we're happy to provide Modbus connection, Profibus, Wi-Fi, Ethernet, whichever suits you, and more likely 4 to 20 milliamp output into a SCADA system. We usually provide 1 to 2 panels with 2 to 4 probes connected.
Just keeping you on your toes, Tom.
Just keep them on my toes. Yeah, I'm liking this. It's good. It's like I never know what's going to come next. I'm going to be interested to see how the guys do this, introducing their setup. So here are some of the locations that we're starting to use this probe, because a probe is only as good as the data it provides. As we say, with the optical setups, you can never rely on that data, but that data has to be useful, not just a random number generator. So we started by looking at the inlet works with a primary clarifier to understand what's coming into a plant. And then we moved down the train, whether it be an aeration system, an anaerobic digester, whether it's some biological removal, phosphorus or nitrogen, or even we can go up the collection system into the network to try and judge maybe what industrial waste is coming down the pipe before you receive it. And then the last point on this is the effluents, of course, and we want to see the best water quality we can. But really what we're trying to understand from our connections with you, and as you will understand from the short introductions that we're going to hear from the guys talking today, is what can we use this data for? When you know what's coming in, that's invaluable information. But how can you optimize treatment further down the line accordingly? How can you use that data? And to help with that, we upload it onto our online platform where you can scan over time and compare different probes. And you have that instantaneous set of information for what's coming in to your plant. So far, in the last 3 years, we have managed to expand all across the world, and here's some of the locations that we have installations. Across the United States, which many of you will be preparing for WEFTEC in the next couple of weeks, we have a number of installations. And of course, our global HQ is this tiny little island just in the middle here, Prince Edward Island in Eastern Canada. So it's a beautiful location to visit. Please come and see us, and hopefully we will see you at WEFTEC. Okay, so now we're going to look at applying it to plant optimization, and we're going to talk to some of our customers that we've been working with this year, and we're going to ask them to give a very brief and short introduction to what they were doing with the probe. And we have a couple of slides from them. Most of the time, SENTRY is applied to these particular challenges. Detecting organic loading and toxic shock at the inlet is where we're talking about. Feed forward control and generating pattern data on what's going on with the treatment works to help give that feed forward prediction to what's going on. However, these guys are going to tell you what they wanted to do and where they are. These case studies, we're going to start with Roberto, who's going to tell us a little bit about what he wanted to do in Milan. And these are case studies that we're currently developing. So as you will appreciate, we're just at the end of summer with these projects, and we're going to be working these up into larger, more detailed case studies and taking these further afield in the coming months. So we're very excited with where we've got to so far. And with that, I think we're going to hand over to Roberto.
Give me one sec. That's not the order that I put the slides in. So
Or we can take this. We can take this time to pull up the pool first.
Oh yeah,
Oh,
that's a great
yes.
idea. Yeah.
Yeah, that's a great idea. Put the poll up.
I will share the screen for you. So
Oh, well, there you go. Roberto has got his slides ready.
Perfect. All right.
There you go. Excellent. So we got a little poll question to keep you all interested. And what we want to know from you guys is, what are you interested in optimizing? And what is the focus for your facility? Please select more than one. I believe that is available for you. But we want to know what you're trying to do and what your challenges are. Most of all, we want to know what your problems are. Of course, panelists and myself, we don't get to vote in this, but please do click on and vote.
The poll will end in 10 seconds.
Fabulous.
Okay, let's see the results.
There we go. So meeting compliance is right up there, and in our ever-changing world, as we see droughts and floods come in the same summer, meeting compliance is a bigger and bigger challenge because we never know what's coming down the line. Certainly in London, we have just been overflowing with water through this very, very rainy and wet summer. And I know our colleagues in California can't get enough water through their networks. And of course, the ever popular lowering of water treatment costs, of course. Yeah, that's good. That's interesting to hear. Thank you, guys. So, Roberto, please.
Yeah, I'm ready. Do you see my screen? Okay.
I see your screen.
Okay, let's go. So I'm just a brief presentation of me and my company. I'm Roberto Di Cosmo. I'm a process engineer in Gruppo K. It's a water utility in a metropolitan area of Milan. We manage and treat the water integrated services, so from aqueduct to wastewater treatment, and we manage and own 40 wastewater treatment plants around the Milan area. And we decided to start this implementation of, I hope just the first one, implementation of the SENTRY sensors in one of our biggest plants, the second one. It's a Pero wastewater treatment plant in northern area of Milan. It's 620,000 population equivalent, and we treat more or less 6,000 cubic meter per hour here. As you can see, these are our usually common daily discharge limits and annual average that you can see around Europe. And we chose this plant because sometimes we noticed some illicit discharges occurring at the inlet of the plant, affecting, for example, also odor emission and something else in the last few years. Okay. This is a brief presentation. Of course, it's a conventional activated sludge plant. So we have the gritting, primary settling, biological treatment with alternate cycle, secondary settling, filtration and disinfection with sodium hypochlorite, and then in next future months we pass to peracetic acid. As I told you, it's common. Let's say it's a conventional activated sludge, but we decided to move to the alternate cycle in order to, let's say, I have a complete automation of the biological system. We have our SCADA where we also bring the signal from the sensors, and we are managing all this with our SCADA. In the next few months, in a control room that will be in our new buildings in the middle of Milan, in the center of Milan. So at the beginning, what did we expect from SENTRY installation? We thought about that. The first thing is that we need to be advised when some illegal or any illegal discharges with an eviction effect will occur. Maybe, who knows? So what's happening when something like this has been found by the sensor? Also, we need to check the BOD concentration or maybe some fractionation of COD in order to see the dynamic fluctuation during the day. And another thing is that we would like to try to move the sensor from a first position in order to check these two, let's say, base things in a secondary position at the disinfection inlet and outlet in order to see Escherichia coli concentration. So at the beginning, we decided to put the two sensors, the inlet of the gritting and at the outlet of primary settling in order to see, of course, the inhibition effect at the inlet and some possible effects of supernatant that come back from digester into biological treatment pumping station. So we installed the sensor there. We put the control panel near the biological treatment station, and we connect everything to with the SIM card, as Tom told before, but also to our SCADA. Just a focus on the installation. Of course, we had to be careful in building this sort of structure to protect the sensor from really high velocity of the flux in our channel. We have some basic issues with communication of SIM card that we solved with changing the operator. And as I told you, we decided to check also the data in our SCADA in order to let's say, control also with other variables and correlate with other many process variables that we have on site. As a first result, of course, we have an adaptation period of 15, let's say 20 days at the beginning. And then we saw the first results, good results, also during rainy period that, of course, in Italy, it's not so much in summer, but it happens. And the system, of course, go back to the normal value, as you see here on the right side of this graph. 20 days ago, more or less, we did a 2-hour sample campaign also to see this fluctuation of dynamics of pollutant, COD, total N, ammonia, phosphorus, and metals, of course, and we noticed this, of course, correlation in value of microbiological activity with these parameters, with a sum of square error higher than 0.85. So we are thinking to do another campaign now that we are not in summer, in order to see the possibility to maybe in the next future replace the influent sensor with or analyzer with this kind of sensor. So at the end, good for us that we did not find any legal discharge in this first 5 months of operation of the system. But of course, the system have its own email alert when some thresholds are exceeded. On the dashboard and also in our SCADA. We noticed this interesting correlation with nutrients, of course, and new ideas are coming on this. We are waiting to move this both sensor in order to fix the effect of disinfection of disinfectant in our new peracetic acid dosing station. And maybe, let's see, I hope to see some correlation with Escherichia coli in the inlet and in the outlet. Of course, we need the help of SENTRY teams. And what I can say is that in this 5 months working period, we have no problem at all with the biomass attached to the sensor, even with some, for example, material stuck in the sensor. It happens, it can be possible, but the sensor resists to any stress. So we are very happy. We are proud of this first installation, and we are waiting to move these 2 sensors and continue this collaboration next year. I hope for many years. And that's all. Thank you, everybody. And if you have any questions, I'm here.
Fabulous, fabulous. Thank you, Roberto. Much appreciated. Grazie, grazie. And please put any questions in the chat for Roberto, and we will come back to answer some questions at the end. And we have a couple of slides now from Jose that Alex is going to share. And I'm going to introduce a little bit on what Jose's been doing, and he's going to tell us all about his project in Spain. There we go. We seem to be getting there.
I think it's working.
Aha, there we go. Fantastic, fantastic. Let's start off. Jose, do you want to introduce who FC Aqualia are and a little bit about your company?
Okay, of course. So Aqualia, it's a global water operator. So we are merged and part of the FCC group. We are a huge construction group, and Aqualia is specialized in the water cycle. So we deal with everything related to water, either drinking water, facilities, networks, and wastewater treatment, of course. So in my case, I belong to the innovation department. So we are developing new products, and hopefully your SENTRY probes help us a lot in this purchase of new technologies and improvement of the already existing assets.
Fabulous, fabulous. Thank you, Jose. So we met Jose a few years ago, and we started a conversation about an industrial client that Aqualia were dealing with. That's obviously slightly different to what Roberto was doing with a municipal client, but a good contrast, I think, here. The client was a industrial client in northwest Spain who was working in the food sector. They were piloting an anaerobic sequence batch reactor. Do you want to tell us a little bit about that batch reactor and what they were doing, Jose?
Of course. So yes, in my region, so we are working, and I'm based in Galicia, which is the northwest region of Spain. And there, everything related to food, and especially to seafood and fish is very powerful. So in this case, we are talking about a processing entity which has a huge revenue and one of the most important player in fish canning worldwide. So they need to improve their wastewater treatment. And in our case, we love anaerobic processes because, as you might be aware, aerobic processes consume a lot of oxygen. We have COD that might be converted into bioenergy. So we wanted to test with them, and the good thing with industrial clients is that normally you need to demonstrate your capabilities, and doing it at pilot scale helped us to get information about their influence, because you know that industrial sector is evolving all the time, and you might find surprises and new things with influence. So we had the chance to test the influence, and the good thing about the SENTRY probe is that we got real-time information about what was happening real-time in the facility, because as Roberto was mentioning, sometimes even in municipal sector, which is very stable, you get surprises and sometimes inhibitions. Imagine in the industrial sector where sometimes they don't have a clue about what's happening into the facility, and you have to treat the water. And sometimes you arrive there at Monday morning and the biology is dead because no one knows why something happened and something arrived to the wastewater treatment plant. So having the signal in real time, we had two probes, one at influent and one inside the anaerobic reactor. And what is marvelous with this real-time information is that you know that SBR work on a time basis. So the good thing about the SENTRY probe is that we had the chance to know when inside the anaerobic reactor the organic matter was already removed, which was wonderful because then it allows us to really, I would say, optimize the time of the cycle, so you don't have to set the time of your cycle just with a time base. You can use this real time, I would call it organic matter signal, to really match your needs and improve a lot, and also meet the regulatory discharge limits. So it was very nice. And then also we had another challenge there, is that we had a very short amount of time to do our experiments. So here you can see, for example, how the signal evolves with the different phases of the anaerobic SBR reactor. So you have an increase within the feeding, and then once you stop the feeding, you reach a peak. and then the organic matter is removed by the bacteria, so the signal drops. And you know, when you see this difference and this plateau, it means that the organic matter has been totally removed. And so with the SENTRY probe, we had the chance to know exactly when the organic matter was removed in the reactor. And then we also recognized some specific details related, for example, with these red regions. That was something we had with an internal recirculation that was somehow bringing some noise into our results. So even it helped during this pilot phase to really adjust the detailed engineering that we needed for the full-scale plant. So actually, I must admit that it brought us real-time information that we normally hadn't. So it was fantastic for us. And then we also noticed when something was rare or strange regarding the influence, because sometimes you get these toxic loads with normally some cleaning agents they add to the industrial wastewater. So we had the chance to discuss with the client and see how we can adjust the results. Here you can see, for example, a profile of the reactor when we hadn't these regular basis, I would say, swinging in the signal. And this was mainly due to something happening beforehand the reactor. So we had the chance, thanks to this real-time information, to talk to the client and ask them what was happening inside the facility. So to summarize, we had somehow a high stress in terms of time for the piloting, and we could analyze carefully. For example, here we can see the daily variations and also what was the effect of, for example, the weekend, right? So normally during the weekend, they perform the cleaning inside the facility. Then during the week, you have a more regular operation. So all this variation, all this information was really crucial for us to build the detailed engineering project for the client. And now we are very happy to say that thanks to this information and thanks to the knowledge we got during this pilot phase with the client, we will probably be awarded with the APCB contract with them. We are talking about an amount of money, it's probably around 4 or 5 million euros. So having this real-time information for technologies which are known, but that still need some innovation, and also some, all these digital tool brings important assets to really jump into the market, convince new customers, and for us to really make an accurate, detailed engineering and gain all the information, what's happening inside the biology, and especially crucial when you're talking about low-growing microorganisms such as anaerobic microorganisms. So thank you, Tom.
Thank you, Jose. Much appreciated. That was excellent, and I appreciate the work. And I'm hoping to come and see Jose very soon. And with both Jose and Roberto, we want to work on a more detailed case study so that we can come back to you and not be so quick and not be so, here's some information. But because I think both these case studies are really interesting. There's some really exciting things going on here, and we're going to continue the work. We've continued the work over the summer with these guys, and we have more data, and we're going to work these up into a bigger case study. And we're going to come back to these. But please, if you have any questions at the moment for Jose, put it in the chat. And then finally, we're just going to have a quick intro to Lorena and what's been going on in Western France. And I appreciate this is a very quick fly by the seat of your pants webinar, just a few minutes for each person. But it's a great intro to some of the exciting work that's been going on this year with SENTRY and the guys here on the call. And please, we will be working these up into more detailed things to dive deeper on these in the future. Lorena, do you want to introduce yourself and tell us about Saint-Georges-de-Didon?
Yes. Well, hi everybody. I am Lorena. I am Uruguayan, but I live in France for the last 3 years. I will be really soon a water treatment engineer in 2 weeks, hopefully. And I am at the end of my 1 year and 2 months internship with the SOR group. So the SOR group is in many countries, but mostly it's a French company, so mostly based in France. And I work as an exploitation water treatment engineer. But for this project, I did a collaboration with the research and development of the SOR group. So because I was in the region, so Saint-Georges-de-Didon is in the Charente-Maritime region, which is next to the Atlantic Ocean, and that means that it's a touristic region mostly in the summer. So this is a wastewater treatment plant that it will go from 8,000 in population equivalent to 64,000 in 2 weeks, mostly July and August. And but the wastewater is purely domestic. There are no industries in the area, so it's like a case control study. Can I have the next slide?
Of course.
Yes, sorry. So we had 2 probes installed, one in the inlet right after the pre-treatment screening, sand and oil removal, and the second one in the outlet. And as I said before, this is purely domestic. Also, we have a COD-BOD ratio that it's pretty much always 2.5, and BOD TKN mostly at 4.2. So no weird. There's nothing weird going on, and so the sorry. So what we were looking for was to know if there was any activity, especially from illicit discharges going on, and also we could appreciate for all the time that the probe was installed how the charges will vary depending on the season. So in blue, for example, is sorry, we could say it's like the setting point. It was when the probe was installed. Then we have in May, is the red one. It's a stable line between the red zones that we decided that we had some alarms going on. Then in June it went up a little bit, and is the red is the green one, and the pink one was July, when everybody was here in town. So we had a lot of influent coming in at the wastewater treatment plant. Also with this, as you may see, it's pretty stable. We also installed an optic probe right next to it, and the reading was awful. We couldn't get anything stable. And actually, with the SENTRY for the past 6 months, we had any noise visible in either the entry or the outlet of the wastewater treatment plant. So that I think is great. Mostly with we had a lot of sludge in the inlet due to recirculation, and it didn't affect at all the reading of the probe. Regarding to the illicit discharges, we noticed that sometimes at night, around 4 p.m., not every night, not every week, we had some pigs showing up. So we are still doing some digging up on the matter. They are minor, but we could trace them to a lot of water coming in at the same time. And it's weird because even though it's a touristic area, like it's relatively small town, so the water will come in between around 6 hours a day and 12 hours a day. So we don't have any water coming in between 1 in the morning and 4 in the morning. So we're still digging up, and we hope it will show something on that side. Regarding what SOAR wants to do with this technology, so this is just to compare some different technologies that would help us to trace some either illicit discharges or toxicity in the influence of mostly, well, not most, only wastewater treatment plants. But also in the future, the one of the objectives is to now we have some process of aeration regulation based on either the ammonium and nitrate, I think, concentrations in the aeration basins, and other ones based on redox. I don't know if that's okay in English. I'm sorry.
That's absolutely right, Lorena. That's fantastic.
So the idea is to test with this technology to see if we can even improve those aeration systems that they cost highly, as Jose said before me. So yes, we hope to continue the work with SENTRY.
Fabulous. Thank you, Lorena. That's much appreciated. We deliberately chose some very contrasting and different types of case studies here. So we have Roberta, which is a big city that has optimization challenges around the size of a big city municipal. We have Jose that has industrial and the challenges of very difficult and complex water, and then Lorena that has a very interesting small town tourist location that has a large increase of dry weather and increase of population during the summer months. So each of those hopefully should match up to individual challenges that some of our audience are coming across. And we hope to do a deeper dive with each of the people here at a later date. But first off, is there any questions from the audience before we finish up with how to get one for my facility?
That should be the #1 question.
Yes, of course. That's always the #1 question. Yeah. Well, it seems all quiet on the western front, but you know, this number one question is, how do I get one for my facility? And if we move on to the next slide, there'll be a whole list of representatives in your area, either reaching out to myself or John Grant, who's also on the call, Pat, Alex Webb for North America. But we also have Natalie Lamb on the line, who's from QCL in the UK. And some of these guys, if you recognize them, D&H, I know, are in California. Pelton are in the Midwest in Ohio. PSI Process are in the New York area. Western Environmental, I know, are in the Southwest, down in Arizona. Wagama up in Germany, I believe. Yeah, so we have a full range of clients and representatives who look after our things. And of course, coming to us direct is always available. I think finally, it's just to thank our guys for today. Is there anything else, Alex, that you would like to add before we go?
Well, I think I'll give everyone an opportunity to ask questions if they have any. We have the Q&A function, we have the chat function, or you can raise your hand and we can unmute you and you can ask your question directly. In the meantime, while we're waiting for any participants to potentially ask questions, I'll ask a quick question to our panelists, which is, what was the thing that surprised you most, or that you weren't really expecting to find when you installed the SENTRY? Was there any either data about your process and your operations, about your other sensing equipment, or just about the equipment itself that really sort of surprised you after a few months of having the SENTRY as a pilot?
So if you want, I can start. What surprised me first was the ease of installation, right? So it was very easy to install and to make it run. And then, of course, I mean, having real data related to the organic matter content, it's something which is very valuable for us, because normally we use either COD or even much worse BOD values, right? So in the best case, you need to wait for several hours until you get your result. And in the worst case, you need to wait for days or weeks. So having this real-time knowledge of what's happening both beforehand and inside your unit, it's something really valuable. And I was really surprised to see how easy and how easy to handle and to maintain, right? Because Tom has highlighted it at the beginning. With other probes, you need to take care. There is some biofilm growing on it, so you need to remove it. So then you never know if you can trust the signal. And here you just plug it in and you forget about it. You read your values and you get knowledge about what's happening. In my case, it was especially interesting due to the fact that normally industrial streams are somehow, when you talk to the people that is in charge of the wastewater, they never know what's happening in the facility itself. So it makes our life as wastewater treatment guys much.
Nope.
That's true. I want to say I agree completely with Jose. And also I will say that you can forget about the maintenance of the system, of the probe, of the sensor. I would like to say something. Before our campaign, we had a really strong rainy period with some material stuck on that safety structure that we build around the sensor. But the sensor, the signal of the sensor continued to give us a pattern with a shift of baseline, let's say, of the signal, and we can continue to check this fluctuation again, also with the material stuck on the sensor. Once we removed, everything go back to the initial, let's say, trend. So it's true, you can forget about the maintenance, at least for this 5 months for us. And of course, the other thing that I want to suggest is that the potential of this kind of let's say, measure correlation and everything else, because we're just looking at some aspects of this possibility. We have many possibilities in disinfection, in anaerobic digestion, in co-digestion, I hope next few months or few years. So this is a big point for everybody, I think, is the possibility open with this kind of sensor.
Fabulous. Yeah. Thank you. Thank you.
I agree with both of them. I was impressed with the no maintenance required, no deviation whatsoever of the data. We didn't even have to put anything around it. We just installed it directly in the water. And even sometimes, if because it happens that sometimes something would go through the screening and it would get stuck around the probe, but the probe would give the same information as it didn't have anything around. So it was nice to see. And I've even seen in the one that was in the outlet, because it was before disinfection, that it had some algae growing around it, and it didn't affect whatsoever the reading. So that's a good thing. I've worked with many probe technologies, and all of them that I've been working with require a lot of maintenance, a lot of metrology involved, a lot of verifications. So with the SENTRY, a huge advantage that it has is that it makes you gain money with no maintenance. Like, you don't need a guy every day to go check, or once a week to go do a measurement verification. So that's a huge point for this technology.
We do have one question for Lorena from our audience about the small spikes. So Tim would just like to confirm if they were detected during the morning hours.
They were mostly at 4 or 5 in the morning, and it was not constant. It was not every day or even every week. So we suspected that it has to do with some illicit discharge. We know it is biological because it went up and not down. So, but we couldn't trace it so far, because it's not something that we will know when it's going to happen. So we keep monitoring if it shows. Sometimes at 4 or 5 in the morning, there's people in the, I don't know how to say, poste de relevage in English. Yes, when maybe find a truck, or we have, since it is a touristic area, there's a lot of campings around. So maybe one that is discharging when it shouldn't be. So yes, that was shown. That was really interesting to see. So far, we didn't have any toxicity coming in, because there are no industries around it here, not even small ones. But we had some really heavy rain weeks, and it was raining too, so we could see that. But the SENTRY probe really behaved really well in the meantime. One other thing that I almost forgot to say is that since we are next to the sea, the water it's a little high on chlorure. And that usually with the optic probes, there's some interferences, even though with the I know with the ICE also selective membranes, they have issues also with the chlorure. So with the SENTRY, again, really steady data all the time.
Yeah, this salinity can cause a lot of problems with the chloride in the seawater, and that's one of the great advantages of SENTRY. We react to the biology that's in there and are not screened by salts or other intrusive salinity. Excellent, excellent. Do we have any more? And I think we're almost coming to our time here.
I don't see any in the chat or in the Q&A, so I think we're good to go.
Fabulous, fabulous. Well, thank you very much for taking part today and all your time, guys. It's very much appreciated, and it's always lovely to see your great faces on these things. But we will be in touch outside this, and thank you to our audience for dialing in today. And hopefully we will be bringing all three of these panelists back to speak in further detail and talk about the continuation of our work here. But as a roller coaster intro to what's been going on in Europe, it's been a pleasure to see everyone, and thank you very much.